In this video, we will be looking at section 2.1. 2.1 deals with linear equations. And quadratic equations. Quadratics are equations that have an x squared as the leading term. They're in the form ax squared plus bx plus c. A linear equation will not have this squared term. Its highest power will be to the first power. Okay, I'll be given these notes and many other notes in Cornell note format. I'll just take you a standard piece of notebook paper and draw a line down about 1/3 of your paper. We will put the key terms and the questions over here and the explanations on this side. And so you can quiz yourself by simply covering up the right side of your paper and looking at what's on the left. You certainly don't have to do your notes my way if you have a method that works for you. First definition, expression. An expression is a combination of variables and or constants. Next definition, equation. Two expressions. With and equals in between. Examples of these two. Just the number 4 by itself, or 4x, or 4x plus 3 plus smiley face. All of these would be expressions. All right, because it could be just a number, a constant. It could be a constant and a variable. It could be a combination. All right, but what distinguishes an expression from an equation is the presence of an equal sign. An equation will have 4 on one side and perhaps 2 plus 1 on the other. Now you know that this statement here is false, but it's still an equation. All right. It is not true that 4 is equal to 2 plus 1. This is an equation. It has an expression on one side, an expression on one side, and equals in the middle. Equations can have variables. It could say 4x equals 8. And it could have other kinds of symbols like my smiley face here. It could be 4x plus 3 is equal to smiley face plus 10. All right. If the expression or the equation has a variable with it, we call it algebraic. All right, this is an algebraic equation. This here is not. This is simply called a closed sentence. It is a statement that does not have any symbol in it other than numbers. And closed statements are either true or false. In this case, this one is false. All right, so the big difference between expression and equation is the presence of an equals. Equation has an equals. That makes sense. Next definition, solution. A solution is a value that makes a statement true. In this example here, 4x equals 8. If x were 2, this would be a true statement because 4 times 2 does indeed equal 8. X equal 2 is the solution to this equation. This closed statement does not have a solution. It is either true or false in its current form. And when we say statement, in this case, we're speaking in an equation because an expression will not have a solution. We'll have some value we can substitute in place of our variable. Equivalent equations. Let me go back up to solution. We can also say solution set. A solution set is simply, sometimes there's more than one solution. Even one number we can say belongs to the solution set. So solution and solution set are virtual synonyms. In the case of a solution set, is a set of numbers that makes the statement true. Equivalent equations are two or more equations with the same solutions. And we can obtain equivalent equations by one of these next two steps. We can use the addition property. Okay. The addition property states if A is equal to B, then if we add some number to both sides, those equations are still equivalent. A plus B is equal to B plus C. Okay. The multiplication property is very similar to this one. We say if A equals B, then we can take some constant C and multiply by both sides. AC is equal to BC. All right, provided that C is not equal to 0. And this statement would still be true if C was equal to 0, but we would not have equivalent equations. All right, so these two properties, the addition property and the multiplication property, they will provide you with equivalent equations. Let's show one example that will illustrate both. Let's say that 4x subtract 2 is set equal to 18. All right, this is an equation. It's two expressions with an equals on each side. We can put any number we want to in for x, but it turns out only one number will give us the solution. Only one number will make this statement true, and I hope that you can see it's going to be 5. 4 times 5 is 20, minus 2 is 18. All right, but this equation is going to help us demonstrate the addition and multiplication property. We want to solve for x, that is, find the value that makes the statement true. I want to get this x by itself. I will begin by adding 2 to both sides. Okay, this is our addition property. All right, so when I add 2 to both sides, just a little separator line here, this side, the negative 2 and the positive 2 add to 0, leaving only 4x. On this side, 18 and 2 is 20. What you see is 5 still satisfies this. 4 times 5 is 20. Just like 4 times 5 was 20 minus 2 is 18. So this equation and this equation, while they look different, we call them equivalent equations because 5 is the solution for both of them. Now, I want to get this x by itself. I can divide by 4, all right? Dividing by 4 on both sides. When I do, 4 divides 4 to leave x, and 20 divided by 4, that is 5. Okay, this is our multiplication property, and I know what you're saying. Wait, that looked like division to me, and indeed that's what I said. It was division, but as hopefully you remember, to say some number like smiley face divided by 4, that is equivalent to saying smiley face times 1/4. All right, so instead of saying divide by 4 here, I could have just as easily said times 1/4. So indeed, I was employing the multiplication property. All right, one final note for this section, the zero product property. Let me come back up here and demonstrate that indeed 5 does satisfy this equation. I'm going to take this number 5 and I'm going to substitute it back into this equation for x. All right, showing my substitution here. So now instead of 4 times x, I'm going to substitute the value 5, subtract 2. Well, 4 times 5 is 20. 20 minus 2 is 18. And this statement here is a true statement. So, since 5 makes this statement true, we say x equals 5 is a solution. What we mean is this value, x5, it makes our original statement there true. All right. One last note for these notes, zero product property. The zero product property states if A times B is equal to 0, then either A is 0 or B is 0, or both. When in math, when we say or, we mean it can be this one or both of them. All right, here's an example of that. We will use this zero product property to solve quadratics. We will see several methods for solving quadratics, but this will be a one of our main methods for solving quadratics, and we're going to use factoring when we do the zero product property. All right, so if we have 3x squared minus 12x is equal to 0. The first step you have to do is make sure your equation is set equal to 0, and we have that here. So once your equation is set equal to 0, then you're going to factor. On this right side, we can see that the greatest common factor, what we look to factor first, is 3x. 3x divides both of these terms. So 3x squared divided by 3x, that's x. Minus 12x divided by 3x, that is minus 4. Well, if we have this factor and this factor multiplied together to give 0, one of them has to be 0. In order to multiply two things together to get 0, one must be 0. Two non-zero numbers will not have a product of 0. So we're going to set each one of these individually equal to 0. We will say 3x is equal to 0, and we will separately say that x minus 4 equals 0. Essentially, we have two equations here. Dividing both sides by 3 on this one, we get that x is 0. Here, adding 4 to both sides, we'll get that x is 4. We think these are solutions. We should take them back into this equation. Substituting 0, you can see that will work rather quickly. 0 squared is 0, 3 times 0 is 0. 12 times 0, 0, 0 minus 0, 0. X equals 0 works, okay? Substituting 4. 4 squared is 16, 3 times that's 48. 12 times 4 is 48. 48 minus 48 is 0. Here, this is our solution set. We would say that x equals 0, 4 are solutions. Okay, that's one way I could state this. Or I could simply say that 0, 4 is the solution set. These are two different ways to write our solutions. They're both solutions. They're two x's. This is not an ordered pair. It's not an x and a y. It's two x's. That concludes the notes for 2.1.